Alright guys, let's look at Newton's second law, otherwise known as force equals mass times acceleration. So this is Newton's second law of motion. Remember, the first law is the law of inertia. The second is F equals ma, essentially. And the third is that forces come in pairs, or you could also say every action has an equal and opposite reaction. So those are the three laws we're talking about here, but we're going to focus on F equals ma today. So the first thing to know is what the formula actually is, and here you can see the triangle. So this means that force is mass times acceleration. You could say that mass is F over a, force over acceleration, or acceleration is force over mass. So you need to be able to use all three variations of the formula, which are also listed right over here on the left. Gravity is something interesting to take note of, because gravity uses this formula. When we want to calculate weight, weight is going to be mass times acceleration due to gravity. So 9.8 meters per second squared times mass is how we derive weight. Remember that weight is a force, and as such it is measured in newtons. You're going to have problems like this that you're going to have to solve, and then this is kind of complicated. If something is launched in the air, then gravity will decelerate the object at 9.8 meters per second squared until it comes to a stop, and when it does, it has reached its maximum height. So let's look at a problem that you might have with something like that, and I'll try to keep it simple since we're starting out today. So let's say, for example, that you have a 1 kilogram ball, and you take the ball and you're going to throw it up. Let me rewrite this over here. You're going to take the ball and you're going to throw it into the air at a speed of, let's say, 20 meters per second. That's pretty fast. Let's say the mass of the ball is 1 kilogram. So what you're going to use is you're going to actually use a different formula related to this. Okay? And that formula is the speed of objects as they fall. And that is delta v, or the change in velocity, otherwise known as acceleration, is equivalent to gravity times time. So this is looking at what acceleration really is. This is how much you're accelerating, this is how much time you're spending accelerating, and this is what's going to actually happen to your velocity. So remember that velocity is, the change in velocity is acceleration. Well, let's look at this example. So that ball is thrown into the air. And what I want to know is, before it begins to fall down, how high can it get? Well, to solve this, like I said again, you're going to be using delta V equals G times T. This is not the same as F equals ma, but it is related to it because it deals with acceleration. So it goes in the air. Again, that is its gravitational pull. So what we're going to look at here is we're going to have to find out what is really going to be occurring here. All right. So one thing to note is that this is irrelevant. In this instance, even though our focus is F equals ma, and we'll get back to that in a second, I wanted to throw this out there. But in this instance, mass is irrelevant. Mass has nothing to do with how fast things fall. So we just need to have the speed here. So as something goes into the air, let's say that you throw it up, it has a speed. At some point it's going to stop because gravity is causing it to slow down. Now, its change in velocity is going to have to go from 20 to 0. So we would say that change in velocity is negative 20 meters per second. It's traveling at 20 and it needs to stop, so we have to subtract 20 to make that happen. That's how I got negative 20. Also, we're not looking at how fast it's going to go when it comes down. We're looking at how much it's going to slow down by. So here, gravity is working against it. So we're going to have negative 9.8 meters per second squared for our gravitational pull. And the question is, how many seconds is it going up in the air? How long is it traveling? We don't know that. We're going to have to find that out. So if you take the change in velocity divided by gravity, what you're going to get for that is you're going to get a time of 2.04 seconds. But that's not my answer. My question was, how high can it get? To find out how far it can get in the air, you're going to take 2.04 and multiply that by 20, and what you're going to get is you're going to get a height of, looks like 40.8 meters, okay? And again, I wanted to throw that out there because you're going to have a question about that on your quiz and most likely on your test. And this seemed like the best place for it because it does deal with gravity. Again, kind of going back, the way we calculate weight is just F equals ma. All right, so again, because this deals with gravity, I wanted to kind of touch on that real quick. One thing to throw out is that forces have a magnitude and direction. So magnitude is going to be the amount or the number of newtons of force that's there. On a vector diagram, which is what this is called, on a vector diagram, usually the line is going to be, the length of the line is going to depend on how much force. So if we're trying to show a picture, show it graphically, we're going to have a longer line to show a greater amount of force and a shorter line to show a smaller amount of force. But you're always, because really velocity is a vector quantity. What that means is it has magnitude, or a number, and direction. So be aware of that. All right, so here we're looking at the vector of the dogs. They're kind of playing around with the cloth in the picture, or maybe that's a toy. And if you look at the overall net force that's going to be involved here, you have an opposing force to the left and another force to the right. So 12 minus 10 is going to give us 2 newtons to the right. Again, we need to say that this is a vector quantity and that the vector is 2 newtons to the right. So I have my magnitude, that's my number, and I have my direction. That's where it's going to go. Let's look at a sample problem here. A 3 kilogram object is propelled with 8 newtons of force. What will the acceleration be? So I'm looking at F equals ma. I'm trying to find my acceleration. So again, I have my mass and I have my force. So to find this, I'm going to have to say that the total is going to be 8 over 3. Put that into your calculator and you should get what? So again, this is just 8 over 3. It's going to give us 2 point, hold on, we'll make sure I get the same answer you guys do. So 8 divided by 3 gives us 2 2/3. So we'll say 2.67. So again, 2.67 meters per second squared. Make sure that when you show acceleration, you always have 2 time units, so meters per second per second. That means that every second that goes by is changing by that many meters per second. So again, 2.67 meters per second squared. All right, next problem. Again, trying to find acceleration. 45 newtons of force was used to accelerate a 9 kilogram object. What is this acceleration? So you would have 45 divided by 9, and that gives you an acceleration of 5 meters per second squared. Remember, it's always expressed in square units for the seconds. All right, and let's do one more. An 8 kilogram object is propelled with an acceleration of 3 meters per second squared. What will its force be? So here you're looking at the amount of force it's going to have. So all you have to do, you have M here, A here. These two multiplied together gives us a force. So 8 times 3 is 24 newtons of force. All right, so those are some samples of what you're going to have on your fever form. Do your best, and we'll talk about this more in class tomorrow.